So, warm welcome to Andrey Sitnik. He's going to be our last speaker.
Hi, everyone. I will speak in English. Hope it will be all right. My Spanish is too small to speak it in Spanish, so English. So, my name is Andrey Sitnik, and I'm not from this company. I'm guest from another company. This is the real name, Evil Martians. Yep. And also, I'm creator of Post CSS and After Prefixer. And as a creator of these tools, I really know that CSS evolved a lot. Like we know that CSS is like a language. A lot of us think that this is think about the old languages, about old CSS language, not the current one. The current one has a lot of new features. For instance, you can use nesting, you can use finally properties, and finally we can make a vertical centering just in few lines of codes. But also, I believe that CSS evolved not only in the way how we write it, but about features and also about the colors. Like a lot of people think that frontend is just a painting of the pixels. And so if we have a new feature of like defining the colors, this is a key of our work because we are all painting the pixels in the colors. Okay, why? Like I think that new CSS will change the way how we define colors. The first thing which is changed and now we like need a new tool is new colors. Like our current screens, they don't display all colors. You know, when you go to the sunset, try to make a picture, then show it to, for instance, your wife, and she don't get why it's so cool, because the screen of your phone it can't render all colors of the earth. Our current screen will render only about 30% of the colors. But the new screens, for instance, on all Apple devices, they can render about 25% more. And we need somehow to use these colors. Another problem, another new feature is design system. Right now, we don't, like our designers don't put every color manually. They use some system behind it, and they need some math to describe the system. And also, we got a new specification called CSS Colors 4, which add a lot of new features. And these features could be helpful for previous problems. And most importantly, the upcoming CSS Color 5 specification will even give us an ability to change the color in our CSS to, for instance, let's increase the lightness of something. Okay, so what is OKLCH, which I show in the slide about the future of CSS? But first, let's start from the syntax. So in CSS Colors 4, they also define a new syntax for all colors functions, for RGB, for HSL, for all the functions which we already use. First, in new CSS, we don't need to put a comma anymore. We can use just a space. Second, instead of having two functions like RGB and RGBA, HSL and HSLA, we right now can use only the one and to put alpha, the opacity, by the slash. And also we can use percents for the opacity. And all these changes could be applied to any functions. And I'm describing these changes because I will use them in my slide. Okay. So what is OKLCH? OKLCH is like functions which define colors. It has 3 digits and also an opacity. The first one is a lightness. It's how like from black to white, how light is a color. The second one is called chroma. It could be like saturation, like from the gray to the most saturated ones, to the most reddish one. And of course, we have a hue, like colors. It goes from red to yellow to blue and going back because this is an angle. So it's very similar to HSL. Like we have the same axis. For instance, let's a few examples. Like if we will put 100% to the lightness, we will have always white colors, obvious. If we will put a 0, it will be dark. If we will put something in between and the chroma will be 0, it will be gray. And if we will put lightness in the between, add some chroma and, for instance, define red color, we will have a red, the simple one. More examples, like To make it a little darker, we just reduce the darkness. To make it a little lighter, we increase the darkness. And for instance, could reduce a chroma. Or by changing hue, we can get a completely different color. But look, here we have completely the same lightness and the chroma. And this is why this green and this pink looks similar. They're complementary. Okay. Why do we need the syntax? Like, why not RGB? Why not hex? Like, we already use them. Like, anyway, most of front-enders just copy-paste the colors from the Figma. Why do we need some new way to define the colors? First reason is that we are not writing to write the code. The code is written to be, we write the code to read it, because we read more than write. We write only answer, and we will read it 3, 5, 10 times in the future. And here is the problem with hex. It's not really readable. Of course, you can read all the numbers. Yeah, it's not a problem. But can you understand these numbers? For instance, like this is the two colors. What one is darker? Who knows the answer? Or maybe they are equal, like the sum of the numbers is equal. It's like even more important questions, like where we will have a contrast issue. Because like if we will find these colors in our real CSS, and they will be like, this is the background, this is color, where we will have a contrast issue. And this question is really important for the application, because if we will have a contrast issue, clients will not be able to read anything. And the answer is here, this simple. Like this one has a good contrast, that one has a different one. But look, like, some of the numbers are completely the same. Why they are so different? Let's compare with OKLCH. In OKLCH, we use a lightness. And here we see that this color is about in the middle of lightness. And so this is obvious darker than that one. And then 80%, like compared to the 100%, it's like not enough distance. And it's by reading the code, we can find a contrast issue, because the numbers difference between 90 and 100 is very small. The second reason is that right now, like why we don't use hex, reasons why we don't use hex. The second reason why we don't use hex is that right now, our designers stop to pick colors randomly by their eyes. They use a system. And for this system, they need a math. They need some sort of formula, which they put parameters and get a color. And this is why we need a math, which will be very useful. And this is why OKLCH is a good option, because it has a very good math. The idea of design system, it's not that like designers have their system and we just copy paste the hex numbers. The idea of design system is that we have a system behind design. And if we have a system behind design, the same system will be in our CSS. If there is a math formula behind colors in their Figma files, for instance, or like some palette generator, we should put this formula into our CSS, so our code will like share the same system. I think this is the main benefit of the design system. Okay, but like OKLCH is very similar to HSL. Why we should not use that one? Like it's HSL, it has this pretty the same, like hue and hue there, saturation and chroma there, lightness and lightness there. Maybe the order is different, but is it everything the same? Okay, the same example, where we have a contrast issue. Like I remind, L is this number, so here we have a 50% of the lightness, and there we have also 50% of the lightness. But where we have the contrast issue, again, we will have it there. But like color has a 100% lightness in HSL, background has a 50% lightness, same here. Why the contrast is different? But compared to the OKLCH, the lightness is different there. The answer is that in HSL, like you have a hue, saturation, and light. L, it's not about lightness. It's unfortunately, like it doesn't represent how our eyes see these colors. And this problem is not with that two colors which I showed. This problem is across the whole spectrum of colors in HSL. Why? Thank you for the asking, because I like to go deeper. The main problem of HSL is that this is a cylindrical color model. So like it has a cylinder, and for like every hue, it has the same amount of the lightness. But our eyes is very complex structure. We have like 3 receptors, and they are not on the equal distance from each other. Unfortunately, this is like a very tricky case, and as a result, we as like humans don't see the same amount of lightness for every colors. Unfortunately, we see colors very differently. We see greens much better than other colors, and you can see it here, and etc. How we can like generate the cylinder in HSL? We just deform the space. We like increase it here to make a perfect cylinder, but this is creating problems. Like let's like put this color. This is KLCH. This is HSL, and let's like see the lightness, like making it black and white. And you see that, and OKLCH we have a perfect gradient, but in OKLCH or in HSL we see that like here this is a much darker one, here is much lighter one, and this is exactly where we deform the space, because all this like randomness of the lightness, the like L, which means light, it's coming from that we deform the space to make it perfect cylinder, because the colors are not perfect cylinder. Okay, next deep topic. New color transformation in CSS. What I like, they have a very tricky syntax, and I love to describe it here. So this is a new syntax where you can change the colors inside CSS, like in SAS. Like who use darker in SAS? But this syntax is more complex. So we write the colors. Here I will use HSL, don't use in the production because HSL is a very shitty format. So we put some color functions, any color functions which we want. Then we put a from, then another color. And then for each component of this color, we put a value. For instance, here we don't change color at all because like we use the same H, same S, and the same L. More interesting examples. Here we took these colors and replace every component, like 5 to 15, 6 to 16, etc., and create the completely new colors. Of course, just an example, had no reasons. But in this example, we use the same H as like here and S like here, but replace 7 with a new value. And we can also use a calc to, for instance, not replace the lightness, but increase it on a special number. The syntax is very complex. It's not obvious. Why do they create this syntax and not like darker and SAS? Yeah, but of course we don't need to use it with like duplicate the numbers. Of course we will use custom properties to like use some colors from the variables. So why not use the same darker? The reason, the main problem is that darker and all SAS functions, they use HSL. And as a result, they have unexpected result. For instance, these two colors, they look similar. But when we make them 40% darker, that the blue one looks like a black, but that one looks like still purple. So because it uses the same HSL, which L means lie, we will have unpredictable results in darker. And this is why we can't just use like make it darker. We need to specify the color space. And in new syntax, in CSS syntax, we can choose what color functions to use, where we need to do these transformations. And like this is a benefit, and this is why we have this complex format. So right now, we don't have the support of this color transformation in every browser. Unfortunately, we don't have it in Firefox, I think, still. So right now, we like can't use this syntax. We can just like copy paste the colors and increase, for instance, lightness to 10%. But in future, like if we will start to be familiar with OKLCH right now, later we will be able to change our colors directly in CSS. For instance, we can define the color of the button, define the background, and automatically define the color on the hover, make it 10% lighter. And we can even do like some sort of mixing, like some sort of automatical system. Here we define that like there is a color of the button, yeah, some color, and On the hover, we will increase the lightness on 10%, and the border will be 20% darker. And then we can just define 3 different buttons with 3 different colors, and they will automatically, like we can define the colors, and they will automatically inject to this formula, and we will have like design system, not inside our Figma, but also inside our CSS files. Okay, what about P3? Like I mentioned that P3 is a big thing. Do you remember that advertisement that your monitor have a 60 million colors? But as I mentioned, it's not enough. It doesn't represent the same, like the all colors which is visible in the Earth. This is because like our current screens can display only this small part of the colors. And this is the all colors visible by human eyes. So it's only 30% of the colors can be rendered on this screen. And modern devices, they go further. They can render more colors. But how we can use them? And this is a problem. Like if we will use HSL, if we will use hex or like RGB, we will not be able to define these colors because these formats, they are limited only to that old monitors and not ready for the future. And this is why OKLCH is also a good option because we can define a new, much more saturated colors. So it's some sort of new retina, but for your landing page. With OKLCH, you can make it much more vibrant for clients with a good hardware. And it's not only about P3. Like OKLCH could be used for future standards. For instance, there is a standard called Rec 2020, which you can find in cinema, like a big TV for movies. And this format, OKLCH, is already ready for this screens. And even for far future, even for some colors, which is like impossible to render on any screen right now, but will be able to render it later. Okay, I described a lot of good things about OKLCH. It could render P3, it is good to transform the colors, but does it have problems? Unfortunately, a little. So it's very good. Could use a lot of good things, but the main problem of OKLCH is that it's not cylindrical. It doesn't create like a cylinder or like a tube, and this is why not every combination of numbers will lead to some colors which could be displayed on our current hardware. It's not a real big problem because browsers, if they see that your color can be displayed on this monitor, they will find the closest one. They'll be like reduce the saturation and lightness and find something which they can render. But you can be aware of it and understand that like you must check that this color is like visible on the modern screens. And also the second problem that this format is very new. It was defined only in 2020. And of course, right now we have like all browsers right now support OKLCH. It's right now in the format. It already has like tools about color pickers, linters, etc. But no Figma support, unfortunately. Like I spoke with the people from the Figma, and they say that they know that this is a good thing, but this is a Figma. Nobody really cares. They will not implement it. So yeah, unfortunately. But the good part, like it was created just 3 years ago, and I'm sure that in Barcelona there is only a very small amount of people who know it. So if you will implement it on your project, maybe it will be the first site in Barcelona which like use OKLCH, which is cool. Okay, so like it's supported right now by many browsers. I mean, maybe not the smallest one, maybe not like internet, the Samsung browser, or, Opera, but all current major browsers are already supported, and this is a good thing. Okay, how to add colors to your project and become the first Barcelona company with OKLCH? So the first one, we will need polyfills because all browsers support it, but that Samsung internet, Opera browser, it's still a browser. It's still some users there. Like there is a lot of users in Asia which use Samsung browser. So don't like, if you don't know the browser, don't ignore it. Like there is a lot of users who use it. So we need a polyfill. There is a very nice polyfill called post-CSS preset end, but also there is a very nice tool called Lightning CSS. This is like a new post-CSS written in Rust. So use it if you can. But if you already have a post-CSS, use this polyfill. It also can it will compile OKLCH to RGB, but also it could support a P3 colors and could convert it to the special format for like a P3 format. Then, step 2, you need to open your CSS file and replace the colors. For instance, you can use our color picker and like convert every colors in your CSS. It could be like require a lot of work. This is why we created a special tool which will automatically find all files and will automatically convert it to the CLCH. So you can do it in one command, 2 commands, like you need to polyfill and then to convert. But there is also a few interesting things. Like I'm very big fan of the stylint. Stylint is like a yeslint, but for the styles. Like, and it will prevent you from mistakes, and also like if your colleagues doesn't do something which you want, like some best practices, you can just like quietly add some rule to the stylint, and the linter will force them to do it. So I like these linters. And the stylint has a lot of rules for colors. For instance, you can like prohibit to use old formats and use only the new one. Or like you can ask them to use a new syntax without commas, because it's cool, like a new one. But the next one, like with all these steps, you will not change your website. It will be the same website as before. It's not cool. The next step is to add P3 colors to your website, because it's like a new retina. It could be much more contrasted, it's much more vivid. So it's like people will like this website more. For instance, do you remember when Android started to get OLED screens, and the screens start like vibrant, like took your soul from your body? And this is because they start to support P3. In all the screens, like all OLED screens can render P3 colors. And so in Android, they did a very bad move. They just take any normal colors and just automatically expand it to the P3 area, so it start to like selling more. And like if Android can sell more with P3 colors, that your landing can sell more as well, because this is more vivid colors. So not do it by your own. Go to your designers, talk to your designers, sit together, explain him or her about the P3 colors. And then you can open, for instance, our color picker. For instance, you have these colors. Then you will need to find the closest one above this line, which like separate the old one, like a grayish world, to the new shiny world of the P3 colors. So find the new colors, take it, and like put to this snippet. Like use a media query. This media query for the screens which support P3. And replace this color to the new version. And the last step, read our article about CLCH. Like it has the same content as I described, but with more details and more technical one, etc. So what we will have if we will switch our website to the CLCH? First, we will increase the code readability, because we will be able to find the contrast issue just by looking to the numbers. Like here, there is a wording, and you see like 95%, 75%, it's about a 20% difference. It's not enough. Like, and if we will render it, it's really not enough. It's hard to read. The second one, your websites will be ready for P3 colors, and this is a big thing right now. Third one, you will be able to edit colors inside your CSS. For instance, if designers didn't get you hover colors, you can create it automatically. Not automatically, like manually, but like copy the normal colors and increase a little or decrease the L, and you will be able to like create a new colors without opening a Photoshop and make a picture, all this not useful stuff. You can be able to do it in the CSS. And also with CLCH, it's very easy to analyze the colors. For instance, it's very easy to understand the contrast, because the L is very like closer to how our eyes see it. You can use just compare L with some constant, and this is how, for instance, on our website we have a different backgrounds, and depending on the background colors, we use a black or white colors according to the CLCH conversion. It's like very easy to use, and you will be able to generate your design system palettes according to the mass. Like right now, there is a very good tool called HueTone. This is a tool which like generates color palettes according to some mass, and you already use CLCH as an engine. And with OKLCH inside your CSS, you will be able even to copy this math, this logic to your CSS. But my favorite part is that with all this RGB hex, we are using colors without respect. We are using the colors without understanding how they work. But if you will go to OKLCH, you will understand why, for instance, like we have less option in green, for instance, yellow, and in green we have more options. You will understand the colors better. And more importantly, you will understand designers better, because with OKLCH and CSS, you will be able to speak with them on the same language. So that's all. This is my Twitter. This is my Mastodon and the Twitter of the company. Thank you. Questions?
We got a question here.
Hi, thank you. Great talk. I have a doubt because I think that what you have talked about is really oriented to P3. And I think that most of the screens that we are using today are in sRGB or even lower standards than that. And I think that, I don't know if there's something that I am missing, but given that P3 is a wider gamut than sRGB, if we have a lower resolution screen or with a lower gamut, we are not having like a smaller window of colors. I mean, if they are not stretching. And the second question is there any chance that this technology can know the display that you have and adapt the colors to that?
Yeah, wait a second. I will like show the source code. Yeah. So yeah, as you mentioned, right now not all devices support it. Unfortunately, all Linux doesn't support it completely because we don't have HDR support, but all Mac devices support it. It's not a lot. Like all iPhones support it, all MacBooks support it, and Android will support it as well. So it's a huge market. It's about 50-30%. But the questions are different. Like, what clients have more money to spend? Clients with expensive devices. And so, like, if you will add OKLCH right now, this is like you will improve your website for the most valuable clients who can like bring more money to the client. This is a short question. The second one, don't worry that like not all devices support it. As usual, we can use a media query. And with this media query, we can like find that this device doesn't support P3. It's even like a screen. So like, for instance, if you have two screens on your machine and you move your website browser window from, for instance, Apple laptop to the remote screen, and this screen doesn't support P3, this media query will understand it. And you will automatically switch back to the standard one. But if you use polyfill, you don't even need to do it manually. Polyfill can automatically generate two different colors, and it will automatically use one of another. It will use like this math, which like finds the closest one. And even the browser could automatically like support it. If you will just create a website only with P3 colors, the old hardware will render it. You just know the result. It could be like a different one that you expect. More questions?
If we have these irregular shapes for Chrome and Hue, how is color animation managed?
Oh, nice question. So the color animation, like, wait a second, like I need some. No. It's not only a color animation, by the way. It's also a gradient. Like the gradients and color animation is the same. We just created two dots, like for instance here and here, and then we create a path through these dots. But this path will be different depending of color model which we use. If we will use, for instance, RGB, it will be a one path. Like even the first and last colors is the same, the path will be different. And this is why in the new CSS, like technically it's a specification called CSS image specification version 4, you can even define what color model you should use for gradients. And for gradients, for instance, you can switch from the RGB to lab. or to OKLab. Don't use OKLCH. It's better to use OKLab for most of the cases, but you can switch it. For animation, the browser will use the color which you describe. So if you describe a color in RGB, I think it will create a path through the. But wait a second. Maybe right now it's a little worse. Maybe right now it's always use RGB. But in the future, like according to the spec, they should use OKLCH. But I think I heard that they use a wrong one. So, but don't care. It's anyway. Animation is short. Nobody will care.
Okay, thinking about this is prepared for the web. What about iOS and Android?
Yeah. So technically, the first framework which supported was iOS. So iOS is supported from 2 years already. So but I'm not iOS, so I'm not sure. Technically in iOS, iOS devices they support P3, not OKLCH. And in the most of the APIs, you define RGB model. So you define the a number of the green, red, green, and blue. And as I know, they don't have OKLCH helper which will convert it to RGB format. RGB could be sRGB, the old one, or P3. P3 is the same RGB format. It uses the same numbers by the different sizes. So as I know, Android and iOS, they don't have OKLCH function, but the OKLCH is very easy to convert. There is a math formulas, and I heard about some libraries for Android development. When you will have the functions which will return RGB format. So this is a way right now. Not really interesting, but still it's possible.
Yeah, thanks a lot for the talk, Andrey. We just want to say that your work really inspires us, like all the front-end community, and we're really glad that you came and that you kindly accepted the invitation. So yeah, give him a round of applause again.